Okay, so in this lecture I'm going to be discussing a couple of new derivative rules. So the first rule is the product rule. And so I showed you in class that if you want to take the derivative of a product, it's not as simple as taking the product of the derivatives. So a simple counterexample is if we take the function x and then the function 1 over x, multiply them together, you get 1. So the derivative is 0. But if you take the derivatives individually and then multiply them, you get x to the negative 2. Negative x to the negative 2, I guess. So at any rate, we can see from that simple example that the product rule has to be more complicated than, for example, the sum and difference rules were. And so it turns out that the rule that we get is that the derivative of f of x times g of x is equal to f prime of x g of x plus g prime of x f of x. And this is assuming that f and g are differentiable functions. Okay, so in class I went through the proof of this using the limit definition of derivative. I'm not going to repeat that here, but I would like to just go through a few examples of how this rule is used. So let's suppose we have a function f of x equals x to the 7th plus 3x to the 4th plus 9. And we want to multiply this by square root of, let's see, I guess I can't really do much here, just let's say square root of x. So one thing we could do to take the derivative of this function is to multiply this thing out. So x square root of x is x to the 1/2, so we can use properties of exponents to get the f of x is equal to x to the 15 over 2 plus 3x to the 9 over 2 plus 9 square root of x. And then we use the power rule to say that f prime of x is equal to 15 over 2 x to the 13 over 2 plus 27 over 2 x to the 7 over 2 plus 9 over. So this is perfectly a fine approach to this problem, but now we have another approach, which is to use the product rule. So our first function for the product rule was playing the role of f of x in this equation will be x to the 7th plus 3x to the 4th plus 9. So since I've already called this f of x, I'll give it a different name here. So I'll call that, let's say, h of x. But that's going to represent my f of x in this equation up here for the product rule. So h of x equals x to the 7th plus 3x to the 4th plus 9. Then h prime of x will be equal to 7x to the 6th plus 12x cubed. And then my g of x will be equal to square root of x. And g prime of x is equal to 1/2 x to the negative 1/2. So now, if I want to find the derivative of this function, I use my product rule. F prime of x is equal to h prime g plus g prime h. And if I just plug in everything that I've calculated above, I get 7x to the 6th plus 12x cubed times g of x, which is square root of x, plus 1 over 2 square root of x, which was g prime of x, times x to the 7th plus 3x to the 4th plus 9. And so we see that the two answers we got with these two methods look fairly different. But what you should find is that if you multiply this out, the form we got from the product rule, and then compare it to this thing, they should give you the same answer. So for a problem like this, which method you prefer is really a matter of choice. But we'll see there are some problems where you can't just multiply the two functions out, and we really do need to use the product rule. So as an example, let's say that we have f of x equals e to the power x, and g of x equals some polynomial, x squared plus 7x plus 9. And let's suppose that we want to consider the function h of x equals the product of these two things. So now we can't just combine these things to get a function that's familiar to us, so we really have to use the product rule. Now you might be wondering, how do we find the derivative of this exponential function, particularly if you didn't see any calculus before? So let me just tell you that the derivative of f in this case is equal to e to the x. So we'll see why this is the case in a few lectures, but for now just take my word for it. And g prime of x we can calculate using the power rule. It's 2x plus 7. And so that means that if we use the product rule, h prime of x is equal to f prime g plus g prime f. And so we just have to plug in all the things that we've calculated to this formula. So f prime was e to the x, g was this thing, plus g prime was 2x plus 7 times e to the x. And this is our final answer. And with these sorts of problems, there's really no need to simplify any further than that. Okay, so that's it for the product rule. The second rule that we looked at was the quotient rule. And so this tells us how to take the derivative of a fraction. So f of x divided by g of x. And so the rule states that the derivative of this is equal to f prime of x g of x minus g prime of x f of x divided by g of x squared. And again, this is if f and g are differentiable functions. Okay, so again, in class I did show a proof of why this is true, but in this video I just want to focus on giving some examples. So let's take a look at the derivative of x plus 7 over x squared plus 3x plus 9. So in this case, our top function will be the f of x is x plus 7. And we can easily calculate the derivative of this function is just 1, since that's the slope of the line. Our g of x will be the function appearing on the bottom. So x squared plus 3x plus 9. And then g prime is equal to 2x plus 3. Okay, so then if we want to use the quotient rule, we just have to plug everything into this formula up here. So the derivative of this thing is going to be equal to f prime g minus g prime f over g squared, which if we plug in all the things we calculated, this is x squared plus 3x plus 9, and then f prime is 1, so we don't need anything else there, minus g prime times f, which is 2x plus 3, times x plus 7, all divided by g squared, which is x squared plus 3x plus 9 squared. And again, for this sort of problem, I do not expect you to do any simplification beyond that. So that's an example of how you can use the quotient rule. And so using these two rules can help us to take derivatives of a much wider class of functions, especially if you use them in combination with each other. So for example, I'll leave it as an exercise for you to work out the details, but suppose I wanted to take the derivative of something like, I don't know, cube root x times x to the 7th plus 1 over x, all divided by x squared plus 1, then, well, again, you could multiply out the numerator and then just use the quotient rule, but another option would be to use the quotient rule directly on this, and then when you take the derivative of the top function, you would use the product rule to calculate the derivative of the product of these two functions. So sometimes you have to use these two rules in conjunction with each other. And that can help you to take derivatives of significantly more complicated functions than what we're able to do before.